Hello class, today we are looking at angle addition postulate proofs. So your essential question is, how do I write proofs? Your learning intention, I'm learning to write proofs involving angle addition. So the warm-up is actually a segment addition proof. Can you complete that? Pause the video and see if you know what to do. Well, I hope you try it on your own. If we're looking at A plus B and B plus C, AB plus BC equals AC. That is our segment addition theorem. And actually, it's a postulate. Okay, what have we done here? Well, AC is equal to AB plus AB. AB plus BC is equal to AC. AB plus AB is equal to AB plus BC. What do we call it when we replace a quantity that is equal to another quantity? Begins with an S. Who takes my place if I'm gone? Substitute, yes. Okay, so if I'm looking on both sides, I've got AB. If I've got that same number on both sides, I can remove it by what? Subtraction. Subtraction, property of equality. And we're done. Okay, so when we look at the angle addition proofs, they're set up like the segment addition proofs. They are a logical thought process. They're a logical argument. So 99% of the time it starts with the given. 100% of the time it ends with what you want to prove. So even if I don't have that first statement there, I know what it is because it has to be given. Okay, so now I've written that down, but I also want to come over here and I want to highlight what I've just done. This is angle 1, and this is angle 3. And those are congruent, their measures are equal. So, the measure of angle 1 plus the measure of angle 2 equals, so I'm adding these two, the measure of angle 3 plus a measure of angle 2. Why can't I do it? Well, that's your addition property of equality. What is, it says the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle JOL. So if I'm looking for JOL, it's the combination of these two angles. So that is your angle addition property. Okay, let's look at the next one. 3 and 4 look awfully similar. What do you think the reason for the statement 4 is? What reason can we give you for doing statement 4? If you look up here, angle 2 and angle 3 make angle KOM, which is what it's talking about. Those two measures added together is equal to angle KOM. So once again, this is your angle addition property. Okay. What have we done here? The measure of angle 2 plus the measure of angle 3 equal the measure of angle 3 plus the measure of angle 2. What property is it that says order does not matter? That is the commutative. Okay, now if I'm looking at this, I've got these are all set up. I can now go to where the measure of angle JOL is equal to the measure of angle KOM. What I have done, I know that these are equal, so when I subtract, I'm using subtraction. I see that they're going to be the same. Okay, I want you to pause the video. I want you to read through what we're trying to prove, and I want you to put in the first statement and the first reason. So we're given EF is perpendicular to EG. D is in the interior of angle EFG. We want to prove that angle EFD and angle EDG or DEG are complementary. So, what do we start with? The given. I'm going to write that so it fits in there a little bit better. Okay, so we know the first statement and reason. Now we're looking at the second reason. It says definition of perpendicular. The definition of perpendicular is what? We know that if we have perpendicular lines, how many degrees do they must they have? Well, they've got to be 90 degrees. So I know that angle FEG, the measure of angle FEG, is equal to 90 degrees. Why? Because I know those are perpendicular. Okay, what comes next? We're adding two things together, angles together. What do we use to add angles together? That would be your angle addition postulate. Okay, for 4, it's substitution. What am I going to substitute? I know that the measure of angle FEG is equal to 90. I've got FEG here, so this is where I'm going to substitute the 90 degrees. So, the measure of angle FED plus the measure of angle DEG is equal to 90 degrees. Okay, if they add up to 90 degrees, what do we know about the angles? Well, that they're complementary, and that is your definition of complementary. And we're done. Oh, I forgot on the first one, but I won't on this one. I'm going to put my little infinity sign to tell my reader I am done with that bad boy. Okay, so pause the video and write the first statement and the first reason and the last reason. Okay, so if we're looking, we're given the measure of angle 2 is equal to 2 times the measure of angle 1. And that is given. Okay, my last statement is a measure of angle 1 is equal to 60 degrees. But now I've got to figure out what comes next. So I'm looking at that second reason, linear pair. What does linear pair mean? Well, that they form a line. So if they form a line, what comes next? So if they make a line, which two angles do make the line? Well, angle 1 and angle 2. So the measure of angle 1 plus the measure of angle 2 will give me 180 degrees. Because that's your definition. If they form a line, then they will add up to 180 degrees. Okay, supplementary. What does supplementary mean? They add up to 180 degrees. So that's all I'm saying, is that those are now supplementary, and that is by definition of supplementary. Definition of supplement. Okay, so now I'm using the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That's your definition of linear pair also. Okay, now I'm going to use substitution. But what can I substitute in? Well, I've got the measure of angle 2 here. I've got the measure of angle 2 up here. So I can actually substitute in what it's equal to. So the measure of angle 1 plus 2 times the measure of angle 2, or 2 times the measure of angle 1, is equal to 180 degrees. Okay. The measure of angle 1 plus 2 times the measure of angle 1. I've got 3 times the measure of angle 1. What have I done? I've simplified. And then finally I get down to the statement, the measure of angle 1 is equal to 60 degrees. I've divided both sides by that 3. So, that was a fun one. Now it's done. Tell the reader I am done. So, I know I'm successful when I can write proofs involving angle addition. So this is just writing proofs